Hello again, Year 8, and welcome to Lesson 2 on acids and alkalis. So today you're going to need a pen, ideally blue or black, for filling in your booklet. You're also going to need a pen in a different colour. Any other colour will do, to show where you've made corrections or marked work. You're also going to need colouring pencils, or crayons or felt tip pens, in case there's any colouring in we need to go through. And you're also going to need a spare sheet of paper. Ideally plain paper, but it can be lined, whatever you've got. If you don't have any paper, there hopefully is a blank sheet at the back of your booklet. So today's lesson objectives, you're going to test what colour red cabbage indicator turns when added to different chemicals. You're going to draw conclusions about chemicals based on experimental observations. And you're going to investigate household objects using red cabbage indicator. Now, as a starter activity, I want you to create a spider diagram showing what you remember from last lesson. So I'll show you what I mean. So a spider diagram, also known as a mind map, should put the title in the middle with a circle or square around it, so in the middle of the page, so acids and alkalis. Then a branch off with the next title, Lesson 1, a circle or square around it. And then I want you to put at least three branches going off with things you remember from last lesson. So as a suggestion, I've got an indicator is, and you could finish that off. Now ideally you'll do this from memory. If you can't think of three things, then you can look in your booklet. But remember, anything you add from looking it up, you need to do in a different coloured pen. And the whole point of this is retrieval practice to help you remember what you did last lesson. And you'll also be creating a resource to use for revision at the end of the module. Now, at the start of each lesson, we're going to do this about the lesson before. So next lesson, we will do one titled Lesson 2. There are 12 lessons in total, so try to leave enough space. But if not to worry, you can use more bits of paper, whatever you prefer. So pause the video while you do your spider diagram just now for things you remember from Lesson 1. Okay, hopefully you finished Lesson 1 on your spider diagram. So we're going to move on. Now, you should remember from last lesson that we found that in acidic solutions, your red cabbage indicator turned red. In neutral solutions, it stayed purple. And in alkaline solutions, it turned yellow or green. Now, I say or green because depending on how strong you make your red cabbage indicator, it can go a bit more green than yellow. We also found that in hydrochloric acid it turned red, and in sodium hydroxide it turned yellow. So now in your booklet you have this table with some laboratory chemicals that we are going to test with the red cabbage indicator. Now as I show you the video, you're going to write in here the colour it turns, and then if that means it is an acid or alkali or neutral. So to start us off, we have ethanoic acid, and you can see the colour here. So remember, you need to put the colour in, and if this means it's an acid, alkali or neutral. Next is hydrochloric acid. Again, you can see the colour here. Then got sodium hydroxide again. You can see the colour again. Sodium carbonate is next, and again you can see the colour. Then got distilled water, and it's sort of bluey purple you've got there. And lastly, you've got sodium chloride. Okay, so I'll now go through the results with you, make sure you've got it all up to date. Remember, if you do make any corrections, to use a different coloured pen. So, your ethanoic acid sort of turned pink or red. It looked more red there because it was quite a strong indicator. And that means it's an acid. So if you've put red here, that is correct. Just sometimes it can be described as pink. Hydrochloric acid turned red, meaning it is an acid. Sodium hydroxide turned yellow again, meaning it is an alkali. Sodium carbonate also turned yellow, meaning it's an alkali. Distilled water was purple, sort of like a bluey purple, meaning it is neutral. And sodium chloride was also purple, meaning it's a neutral. Now just before moving on, see if you can add the colours in Welsh. You might want to use it down the side. Just describe the colours in Welsh as well. Pause the video if you need to. So next you need to write your conclusion. So pause the video to write your conclusion. Okay, so I'm going to show you my conclusion. As before, you don't need to match mine word for word. It's just to have the same key points. So my conclusion was ethanoic acid and hydrochloric acid are both acids. This is shown by them turning pink and red when red cabbage indicator is added. Sodium hydroxide and sodium carbonate are alkali. This is shown by them turning blue and yellow-green when red cabbage's indicator is added. Distilled water and sodium chloride are neutral, and the red cabbage stayed purple when added to these. So if you do make any corrections, make sure you do it in a different coloured pen. And remember, it doesn't need to be the same. You don't need to copy this as long as you've got the same general idea. So next, we're going to look at some household substances. So before we go to the video, I want you to come up with the titles for this table. So pause the video and put in the titles for the different columns. So hopefully you got something on the line of substance tested, colour indicator turned, and whether that means it's acid, alkali or neutral. So what we're going to do is I'll show you the video. You'll fill in the substance as we go down, what colour it turns, and if that means it's acid, alkali or neutral. Okay, our first one is Cif, and Cif is a surface cleaner for, say, cleaning the stovetop or kitchen sides. You can see the colour it's turned here with the red cabbage indicator. Next is orange juice, and you can see the colour it's turned here. So make sure you put orange juice down the left-hand column, the colour in the middle, and on the right if it's an acid or an alkali. See shampoo here. That's your next one. Then you've got soap. See here what colour that turned. Then ketchup. See what colour that turned. And that's not just the colour of the ketchup, that's the colour it's turned after the red cabbage indicator has been added. Then lastly, toothpaste. You can see the colour it's turned there. So make sure you've got all these filled in. Rewind the video if you need to. Okay, so now we'll go through them. So remember, if you do need to make any corrections, to do that in a different coloured pen. So the first one we've got is Cif, which is a surface cleaner, and that turned yellow, meaning it is alkali. Then had orange juice, which turned red, meaning it is an acid. Shampoo stayed a bluey purple, meaning it's neutral. Soap turned yellow, meaning it is alkali. Ketchup was red, meaning it is an acid. And toothpaste also stayed a purpley blue, meaning it is neutral. And again, I want you to pause the video and fill in a conclusion. Okay, I'll show you my conclusion now. Remember, if you make any corrections, to use a different coloured pen, and that you don't need to match mine exactly. So mine was orange juice and ketchup are acids. I know this because they turned the red cabbage indicator pink or red. Cif and soap are alkalis. I know this because they turned the red cabbage indicator yellow. The shampoo and toothpaste are neutral as they did not change the colour of the red cabbage indicator. So today's fun fact zone, as I said, you'll have one of these each lesson. So about this intelligent man here. His name is Robert Boyle, and he was alive in the 17th century. He was an Irish chemist and is regarded by many as one of the first modern scientists. He wanted to find an easy way to identify acids and alkalis. He kept getting really annoyed that people around him kept leaving flasks about without labelling them, and he had no way of knowing what was in them, if it was an acid, an alkali, or water. Now, he knew that workers in France used plant juices to dye silk clothes, and they would use the juices from the same plants to get different colours. So he decided to test what they used with substances he knew were acids and alkalis and neutral. And in 1663, he discovered that the juice from vegetables like red cabbage changed colour when an acid or alkali was present. And this is the first known description of using red cabbage extract as an indicator. Okay, so we've looked at red cabbage, but there are other edible indicators. Edible meaning safe to eat. For example, here we're going from very acidic citric acid to vinegar to just water, baking soda and drain cleaner, which is a strong alkali. In this one, they haven't added as much red cabbage as us, so you've got this different profile. Above it, you've got beet, which is beetroot. And you can see in acid and neutral, it's the same colour, but in a strong alkali, it turns yellow, so it can be used as an indicator for alkali. So pause the video and have a look at what other edible indicators you can find and what colours they change. And you might want to write this down at the back of your booklet on a spare bit of paper, as long as you keep it all safe with your booklet. So pause the video while you do this. Okay, and just a reminder of the link I put up for the last lesson for try this at home. We've got a link for making the red cabbage indicator at home, and you can then use it to test some different substances about your house yourself, as long as you have an adult's permission and help, and use that to make a piece of art that looks like a rainbow. So hopefully you'll be able to have a go at this at home, because it is a lot of fun to do. And then lastly, you need to test your knowledge. So I want you to do the short self-marking quiz labelled Lesson 2 to make sure you've checked your understanding and the teacher can see how you're doing. And remember to add any new keywords to the table at the front of your booklet. So thank you, Year 8. That's everything for today's lesson.